This will be a demonstration of the Quickdraw Weaving program's ability to import weaving data from Excel or other programs. In this case, let me open Excel. The spreadsheet is included with the release directory on the Quickdraw versions. In this case, I've created a simple little spreadsheet. So let me select a chunk of it. In this case, I'm going to control the number of shafts, the threading sequence. I want to be able to control the colors, the thread sizes, as well as the thread thickness. First question, I've selected that, and if I hit a copy, just for reference, if I go down and open a notepad and paste that in down there, the numbers from Excel are simply pasted in as ASCII numbers, and they are tab delimited, so anything that generates a tab delimited sequence could be used this way. I'm going to ignore that. So I've got that sequence on the copy buffer. There are several places I can paste that. From a warp weft editor, the Excel import is here. I can also paste it as a name draft or as well as the pattern line on network drafts. I'll talk about those in a minute. So I'm going to import the basic threading information. And that is the pattern that it's notice the threading sequences starts at treadle 1, 2, 3, 4. So if I go back over here to the Excel side, I can see the treadling sequence. I can see the thread numbers. Now you'll notice the palette here had multiple colors. The palette I pasted was only a monochrome palette. So let me ask for the rest of the rainbow colors. And let me import the Excel again. This time it is imported the color indexes from the palette so that I can do that any way I want to. I could use shades of gray, blue, red, whatever I wanted to do. You'll notice the threading sequences there. The colors have been filled in. You'll also notice the thread sizes and spacing has also been controlled. So there's actually more power here than there is normally on the editor, where you have control over thread size but not necessarily the spacing. So that gives me the basic capability of creating a pattern out of using Excel as a source. Now the other things I can also do, I can import that as a lift plan. Now let me go back for a second. You'll notice the threading sequences here are straight shaft numbers. And when you're dealing with single shaft, that's fine. When I go to a lift plan, the question of how best to define a lift plan, I can identify it as shaft numbers separated by commas. For example, if I copy that lift plan and I import that, so it will import exactly what I've told it to import. So there I see the lift plan that I'd imported, and it hadn't changed the other information. Now the formatting on this, the first column tells me what it is I want to import, and the next columns are simply the data sequence. So for example, if I ask for a lift plan that's weighted, now I need to go back through and figure out how to identify that. So what it actually uses is bit weights. So for shafts 1 through 3, 4, 5, it will use the binary powers of that, which is what the weights here would show. So if I want shafts 1 and 2, I would actually ask for 1 plus 2 is 3. Or if I wanted shafts 3 and 4, it would 4 plus 8 is 12. So from a human being's point of view, the lift plan separated by strings is easier. If you're trying to generate it dynamically from Excel and those tools, combining bits this way is an easier way to do it. So if I asked for the same, this would be the same lift plan here. So it's not really going to show much difference. Let me go through and change that gives me a different lift plan. So if I paste the Excel import, it goes back to what it had. So it's now replaced that lift plan with the new one. So that's two different ways to do exactly the same thing. And I have the same tools when I define the tie-up. So as in a lift plan, if I want to do a tie-up, I can do that the same way here. If I copy that, as I import that, it's now shifted back to a tie-up. It's actually shifted to a multi-treadle, but it's now pasted that tie-up in. I can do the same thing with the tie-up on the weighted bits. Now, another thing I can do is also I can import the text string from a name draft. So if I copy that, actually I could paste that at any one of the Excel imports here. If I paste it, it recognizes the name draft, so it's kind of filled in the equivalent characters of those letters from the Excel spreadsheet. I can import that again here. I can then generate name drafts based on those patterns. It was a straight twill, so it's going to give me pretty straightforward patterns there. The other thing I can also do is come back in with the design lines in network drafting. So in this case, let me ask for network shafts, and I can directly control all 4 of the ribbons should I want to. So I'll just grab this whole set, copy that, and if I paste that, it's now set up the pattern line. This is, if you look over here at what that pattern line was, it was a straight little triangle, flats out for a while, and then another triangle at the end. So that's what those filled in from right to left. And the ribbons, there's actually 3 different ways to define the ribbons here. I can do it as comma-separated fields, as I did on the tie-up and the lift plans, or I can use weighted. As well as with ribbons, it's convenient to say where does it start and how wide is the ribbon. So there's actually 3 different ways here to define a ribbon. And if I ask for ribbon 1, 2 looks the same, 3 looks the same. So I've actually got an extremely powerful capability of defining a pattern however I want to, algorithmically, and do whatever I want to. In Excel, I can easily also implement the equivalent of a digitization in network drafting, as well as telescoping. Thank you.